Hi, madam. I'm Yuan, and our group is Group 2 in DO1A. Today, we are going to answer the question of the assignments. There are four questions. The first question is about the algebraic concepts and linear functions, and the second question is about the linear programming, and the third question is mathematics in finance, and the last one is metrics. And these are our group members. Yuan is me. I'm responsible for the question 2, the linear programming, and Benjamin Tang is responsible for question 4, the matrix, and LUQMAN is responsible for the question 1, the algebraic concept and the linear function, and Kurt is responsible for question 3, the mathematics in finance.
Assalamualaikum. Hi, I'm Muhammad LUQMAN, and I will be covering question 1, which covers topic 1 and topic 2, which is algebraic concept and linear function. So for question 1a is to solve x squared minus 3x minus 10 equals to 0 by using factoring method. So to factor the quadratic equation, we need to find two numbers whose product is equals to the constant term, which is negative 10, and whose sum is equals to the coefficient of the linear term, which is negative 3. So the factor of negative 10 that satisfy this condition are negative 5 and 2, since negative 5 times 2 equals to negative 10, and negative 5 plus 2 equals to negative 3. So now we can rewrite the equation as x squared minus 5x plus 2x minus 10 equals to 0. Next, we are going to group the terms and factor by grouping. So we are going to get x squared minus 5x in the bracket plus 2x negative 2x minus 10 in the bracket equals to 0. So now we can factor out the common terms from each group, which is first group, we got the common term of x because x squared divided by x and 5x divided by x. And the second group, the common terms is 2 because 2x divided by 2 and 10 divided by 2. So we got x multiplied by x minus 5 in the bracket plus 2 multiplied by x minus 5 in the bracket equals to 0. So now we can factor out the common terms from each group, which is x minus 5. So what we're going to do, we are going to bracket x plus 2 in the bracket multiplied by x minus 5 in the bracket equals to 0. So to find the solution for x, we can set each factor equals to 0. So the first factor is x plus 2 equals to 0. We take 2 to the right and we got x equals to negative 2. And the second factor, x minus 5 equals to 0. And we take negative 5 to the right and we got x equals to 5. Therefore, the solutions to the equation x squared uh, minus 3x minus 10 equals to 0 are x equals to negative 2 and x equals to 5. So for question 1b is to find the equation of a straight line perpendicular to the line 3x plus 2y plus 7 equals to 0, and line with y-intercept is negative 2 units. So to find the equation of a line perpendicular to the line 3x plus 2y plus 7 equals to 0, we need to find the slope of the given line first. So we need to rearrange the equation into the equation of a straight line, which is y equals to mx plus c. So we can rearrange it as 2y equals to negative 3x minus 7. But we only need one y, so we can bring the 2 to the right. So we got y equals to negative 3 per 2x minus 7 per 2. So according to the equation, our slope is m equals to negative 3 per 2. So now we can find the slope for the perpendicular line by flipping the sign and taking the reciprocal. Reciprocal. So the slope of the new line, the perpendicular line, will be m equals to 2 per 3. And from the equation, from the question, the new line will have y-intercept of negative 2. So now we have the slope of the new line m equals to 2 per 3 and y-intercept c equals to negative 2, which we can substitute into the equation of the straight line y equals to mx plus c. So now, after substituting, we are going to get y equals to 2 per 3x minus 2. Therefore, the equation for the straight line perpendicular to the 3x plus 2y plus 7 equals to 0, and with y-intercept of 2 units is y equals to 2 per 3x minus 2. So now we got to question 1c. Edris Biking Company manufactures and sells bikes. Each bike costs 50 ringgit to make, and the company's fixed costs are 2,000 ringgit. In addition, Edri knows that the price of each bike is 150 ringgit. And the first question is to find the cost and the revenue function. So the cost function is variable cost plus fixed cost, which in this case is each byte cost, which is 50 ringgit, plus the fixed cost, 2000 ringgit. So cost function Cx equals to 50x plus 2000, where x represents the number of bikes produced. So for the revenue function is just price per unit times quantity sold. So which in this case is the price of each bike, which is 150. So the revenue function is Rx equals to 150x, where x represents the number of bikes sold. So for question C2 is to find the break-even quantity, which the break-even quantity is revenue equals to cost, which we already got from the previous question. So Rx equals to Cx. So, so we got 150x equals to 50x plus 2000, and we group the x together. 150x minus 50x equals to 2000, and we solve for the left side, and we got 100x equals 2000, but we only need one x, so we bring the 100 to the right, and so we got x equals to 2000 divided by 100, and we are left with x equals to 20. Therefore, the break-even quantity is 20 bytes. So for question C3 is to find the break-even revenue. So the break-even revenue is simply the product of the break-even quantity and the price per byte. So break-even revenue actually equals to price per byte times break-even quantity. So we get Rx equals to 150x. R, we put in the break-even quantity 20 equals to 150 times 20, which is the break-even quantity. So now we got 3,000 ringgit. Therefore, the break-even revenue is 3,000 ringgit. Done.
So, hello, madam. I'm Guang Yuan, and I will be responsible for question 2 of the assignment questions, which is linear programming. So, through the question, we know that there are two sizes of the shoe cabinets, which is large and small. The large one takes 4 hours to build, and the small one takes 2 hours to build. The profit of the large shoe cabinet is 60 ringgit, and the small one is 30 ringgit. And then we know that the carpenter is only can spend 24 hours per week to making the shoe cabinets, and at least 2 large and 2 small cabinets in each week. So after that, we formulate the linear programming problem that maximize profit. We can organize the information first, like draw the table as below that I provided. So we can write down the content of the title of the table first: large shoe cabinet, small shoe cabinet, and the time, and carpentry, and the profit per cabinet. As just now we know that the large one used 4 hours to build, and the small one used 2 hours to build. We can write down at the carpentry column first, and then the time we know that limited as 24 hours per week. The question also mentioned that the profit per cabinet is 16 ringgit for the large one, the 30 ringgit for the small one. So we write into the table. After that, we can set X. We set X as the number of large shoe cabinets and produced and sold. And the Y is for the small one, is for the small shoe cabinets produced and sold. So after we draw the table and set the XY, we can start to formulate the function of profit to maximize the constraints of carpentry and the number of units. So first we find the profit to maximize. We set P as the profit, and we just now we set X is the large cabinet and the Y is for small cabinet. We put into the profit that we already draw as 60 as the large one, we can get 60x, and the small one is 30, we can get 30y. So we plus them. So we can get the profit to maximize is P equal to 60x plus 30y. And the contrast of carpentry is given by 4x plus 2y lower or equal to 24. How we get this? We can look at the carpentry column. The large one is only can use 4 hours to build one, and the small one is 2 hours to build one. And the limited time is 24 hours per week, so that we set the large one is 4x plus the small one is 2y lower and equal to the limited time 24 hours per week. And through the question we know that per week is at least we need to build two small shoe cabinets and large shoe cabinets. So we know that the large one is s greater than and equal to 2, and the y is greater than and equal to 2. So through the function that we get just now, we can set the maximized function is p equal to 60x plus 30y, and subject to 4x plus 2y lower or equal to 24, and the limited and the constraint of the units is s greater than or equal to 2 and the y is greater than or equal to 2. The question B is graph the feasible region. So we can find the 2 points of the line 4x plus 2y lower or equal to 24 first. We find the x-intercept and set y equal to 0. So we can get 4x plus 2 multiplied by 0 equal to 24. And we can calculate, then we can get the x equal to 6 when y equal to 0. After that, we can find y-intercept and set x equal to 0. Same. 4 multiplied by 0 and plus 2y equal to 24. And after calculate, we can get y equal to 12 when x equal to 0. By using the function of the line 4x plus 2y equal to 24, we can get 2 points, which is s equal to 0, y equal to 12, and y equal to 0, x equal to 6. So that we draw a line pass through these 2 points, so we can get the graph as I provided. So after that, we find the feasible region of 4x plus 2y lower or equal to 24. We can use any point to find this region. For example, I use 0, 0, so means that the s equal to 0, y equal to 0. And then I put into the function, we know that the 4 multiplied by 0 plus 2 multiplied by 0 lower or equal to 24, we can get the answer 0 lower or equal to 24. So means that the the point is in the region of this function, and then so we know that the feasible region is through this point position as the graph that I provided. So after that, we draw the line greater than or equal to 2, y greater than or equal to 2. As the graph that I provided is the x equal to 2 and the y equal to 2. After that, we find the feasible region of s greater than or equal to 2, y greater than or equal to 2. The first picture is s greater than or equal to 2 and y equal to 2. The s greater than or equal to 2 is the feasible region, so the orange color highlighted is the feasible region of that, and y equal to 2 is only the line. Same, the second picture is x equal to 2, y greater than or equal to 2. The y greater than or equal to 2 is the feasible region that I highlighted as blue color, and the x equal to 2 is only the line. So we combine them, we can get the feasible region of these two is the red color one that they already overlapping. And then we need to find the final graph, which is using the first graph and the second graph to combine and find the overlapping region, so that we can get the final graph as the third graph that I provided. So the question C is we need to find how many small and large shoe cabinets the carpenter should build to maximize the profit. And then we need to refer back to the graph of question B. There are three corners there in the graph in the around the visible region. So we set the first point, the first corner as LP1. How we get this point? We can use the intersect formula, which is use the both line to find it. As we know, there are x equal to 2 and 4x plus 2y equal to 24 for the intersect of LP1. So we use the x equal to 2 put into the function of 4x plus 2y equal to 24. We know that 4 multiplied by 2 plus 2y equal to 24, and then we calculate, we can get y equal to 8. So the LP1 is 2 as the x and y as the 8. And then the LP1 LP2 is same. Use the both line to find it. We know that the y equal to 2 is a line of that, and what and 4x plus 2y equal to 24. So we put y equal to 2 into the formula, 4x plus 2y equal to 24. And then we know that 4x plus 2 multiplied by 2 equal to 24. After we calculate, we can get s equal to 5. So the LP2 is 5 and 2, the SY, the corners. And the LP3 is, we can just look with our eyes. We can also use the intercept formula, as we know s equal to 2 and y equal to 2, so that we know that LP3 is 2, 2. So by using the method of corners, we calculate the 3 points in with the formula that we find in the beginning at the question A, which is P equal to 60x plus 30y to find the maximized profit. So we put the corners as 2, 2, as the x equal to 2 and y equal to 2 into the function, and then we calculate, we can get 180 of 2, 2. And then 2, 8 is, we can calculate as, and we can get the answer as 360. And 5, 2, we calculate, after we calculate, we also get the 360. So there are two maximized number here. So both of these, we know that is the maximized profit that we can get the point. So as we and also we already set x is the large shoe cabinets and y is the small shoe cabinets. So we write into the conclusion, we know that the answer is 2 large and 8 small shoe cabinets, or 5 large and 2 small shoes cabinet is the and the carpenter should build to maximize the profit.
Assalamualaikum. Hi, my name is Kurt, and I will be covering question 3, which is topic 4, mathematics for finance. Okay, to solve the question A, first we use this formula, which is A equal P plus I, and then after you get that, you P, you multiply 1 plus RT. Okay, so the P is 1,100, and the R is 5%, which is the rate, and the T is 9, which is 9 years. Okay, and then I just put the PRT inside the formula, and then get the answer is this, 22.91, and then I accumulate all the totals, so I get the, which is 1,100 plus 22.91, and then you get the RM, 1,122.91, 0.91. Okay, for question B, to get the total of money that will be in the account after 5 years, first we solve it by using this formula, which is A equal P multiply 1 plus IN. So the P is 5,000 ringgit and the R is 3%, and the T is 5 years and M is 2 because of interest compounded semi-annually. Okay, to get the N, I 2 multiplied by 5, which I get 10. And then to get the I is 3 divided by 2, you get 50%, which I convert it to point, you get 0.015. So, and then I just put the P, and I and N in the formula, and then just equal it. And so the answer is 5,802.70 ringgit. Okay, for question C, the question asks for how much money should the insurance company invest now at 2.4% compounded monthly to guarantee that all the payments can be made. Okay, to solve this question, I use the formula P equal R in bracket 1 minus in bracket 1 plus I, closing bracket, negative N, and then you divide by I. Okay, so the money that the insurance company promised to pay every month is total of 500 ringgit, and then the interest rate is 2.4%, which I already converted to 0.024, and then the T is 5%. The T is 5 years. The M is 12 because it's monthly, and the N I do 12 multiplied by 5, and then I get 60. Okay, and then I just put all the information into the formulas, which I equate, and then I get the total of 28,243.32 ringgit. Okay, for question D, the question is to find the amount of each quarterly payment to be made into the retirement fund to accumulate total of $200,000 in 20 years at 5% interest per year compounded quantity. Okay, to solve the question, we use the formula R equal SI divided by 1 plus I, and 1 plus I n minus 1. But before that, we have to find the A first to use this formula. So to find A, I use this formula, which is A equal P in bracket 1 plus I n. Okay, so I just put the information on the text on the formula below. As you can see, 5,000 in bracket 1 plus 0.05 divided by 4, and then for n is 80, and then you get a total of 13,507.4247. Right, after that, we minus the total of 200,000 with the A that we calculate, and then you get 186,492.5753. Okay, and then after that, lastly, we can use the formula, which is SI, the R1, to get the quarterly payment to be made into this retirement fund account. Okay, so I just put the information based on the what we calculated before on the formula, which is 186,492.5753. Okay, in bracket 0.05 divided by 4 in bracket, and then you divide by in bracket 1 plus 0.05 divided by 4 in bracket, for n is 80, and then you minus 1. So you get the total of $1,370.07. Okay, for questions E, the question asks for what is the payment amount. Okay, to get the payment amount, first, the formula that I use to solve the question is R equal PI divided by 1 minus in bracket 1 plus I, closing bracket, negative N. Okay, so the the I is 0.0.5, the N is the N is 1 multiplied by 6, which you get 6. Okay, so and then I just put all the information inside the formula and I total up, which I get the answer $969.39.
So hello madam, my name is Benjamin Tang and I will be responsible for question 4 of the assignment questions, which is matrix. So for question 4, it requires us to solve the following system using the inverse of matrix. So the first step we should do is to list out the A, the X, and the B, just as it shows here. So usually for A, I usually do it row by row, and you must also pay attention on the negative or positive sign to avoid any error. So for the first row, we have 5, 15, and 56. On the second row, we have -4, -11, and -41. Then for the third row, we have negative x, so we put it as -1. Then we have -3 and -11. So for the x is the symbols that are used in the questions. So as you can see in the question, we have x, y, z. So the x bracket will be x, y, z. So for B are the numbers behind the equal symbol. So in this question, we have 35, -26, and -7. So that will be all for this step, and we will be moving forward. So now that we have identified the A, S, and B, let's proceed to find minor A. So the first step of finding minor A will be identifying the M11 first. So as usual, I'll be going through the row by row. So to find M11, we'll be looking at A11, which is 5. So we must cut by row and column and see what's left inside. So what's left inside, we will be having -11, -41, -3, and -11. So moving on, we'll be finding M12. So we'll be looking at A12, which is 15. So as usual, we'll be cutting by row and column. So we have -4, -1, -41, and -11 left inside. So for the others, it is the same concept. Just cut row by column, like M13. So we look at A13, we have 56. So we cut by row and column. So we have -4, -11, -1, and -3 left inside. So for the others, it's the same concept. So yeah. So after we complete all those, we must cross multiplication, then minus them. So for M11, we have -11 times -11. Then we must minus the -3 and -41. So M12, same, -4 times -11 minus -1 times -41. So for the others, it will be the same. So after we done all those, the final answer will be M11, -2, M12, 3, then there's 1, 310, 195. So that will be the answer for minor A. So after we find minor A, our next step is to find the cofactor of A and cofactor A transpose. Then we find the determinant of matrix A. So for our cofactor A, we must always refer to our minor A. However, with a twist, because for cofactor A, the first row it will be positive, negative, positive. Then for the second row, it will be negative, positive, negative. Then for the third row, it will be the same as our first row, which is positive, negative, positive. So what I mean by referring to our minor a, because we must multiply our minor a with the positive and negative sign. Like for example, for our minor a, M11 is negative 2, right? So negative 2 times a times positive sign, it will remain the same as negative 2. However, for our M12 on our minor a is positive 3. So positive 3 times negative sign, it will be negative 3. So it will change to negative 3 for our cofactor. Then for our M13, on our minor a is 1. So 1 times positive sign, it will be remain the same as 1. So it will remain the same as 1. Then for our second row, on our cofactor, our M21 is negative 3. This is because this placement is negative first. So on our minor a is positive 3. So positive 3 times negative sign, it will be negative. So it is negative 3. Then for our middle one, it is positive. On our minor a is positive 1. So times positive 1 is 1. Then for 0, it is the same. Then for the third row, it is the same concept as our first row. So after we complete our cofactor A, we proceed to cofactor A transpose. So A transpose is actually quite easy. It's basically our row became our column. Like for example, on our first row is negative 2, negative 3, and positive 1, right? So we convert it to our column, our first column. So our first column will be negative 2, negative 3, negative 1. Then the same for the others. Our row become column. So negative 3, positive 1, 0. So it will be our column for our second column. Then there's 1, negative 19, and 5. As usual, also column, row to column. So that's how the cofactor A transpose work. So after we've done all that, we are able to find our determinant of matrix A. So the formula of matrix A, the determinant, it is A11 times C11, then we plus with A12 times C12, then plus C A13 times C13. That's how we got our determinant. So for our A11 it is 5. Then for our C11 is negative 2, which is our cofactor. Then plus our A12, then C12, then plus A13, which is 36, then C13, which is positive 1. So our determinant is 1, 1. So that's how we got our determinant. So now that we know that our determinant is 1, let's proceed to the next step. So firstly, we must always put our determinant on the left to divide, and we should times row by column. And it is also important to know that the positive and the negative sign is quite important because it represents the plus and minus. Like for example, negative 2 times 35, then minus 3 times negative 26, because it is negative, so it's minus. Then plus 1, because it's positive, times negative 7. While for the second row, negative 3 times 35, then plus 1, because it's positive, times 26, negative 26. Then minus 19 times negative 7. Then for the last row, 1 times 35, then plus 0 times negative 26, then plus 5 times negative 7. So with all that calculated, we will be getting x1, y2, and 0. And we don't have to divide because it is 1 only. So yeah, the answer is x1, y2, and 2, 0. So that will be all for these questions. So that will be all for our business mathematics video presentation. We hope that Madam enjoyed watching. We also would like to thank Madam for this opportunity because it is also one of the fun way to do our revision for our final. So thanks a lot, Madam.